Thanks, Mark.
Thanks, John. I didn't realize I was a favourite. I didn't know I was up next, so thanks for that. So yeah, I'm Mark Hamilton, Managing Director of Scott Renewables Tidal Power. We've been on the go now for about 12 years since Barry Johnson, our CEO, started the company up in Orkney. And I'm here today to give you an update on where we are with technology development and where we see us and the industry going over the next 10 to 15 years. I always start off my presentations with a little bit of competitor bashing. Unfortunately, I don't think there's anybody in the room from these companies, hopefully. But the point I always make with this is that these turbines will work. Are they going to be cost effective? That remains to be seen. We feel that the cost to install such technologies, such turbines on the seabed are going to be prohibitively expensive if you're reliant on the use of large and expensive installation vessels. We feel that that is going to be a big problem for these guys when it comes to getting their costs to where they need to be. There are developments in installation vessel technology looking for lower cost installation means, and there is some good progress being made, but we feel that it needed a different approach from the start, the more marine engineering approach that Ray talked about earlier, and that's what we're all about. So we kind of started with the vessel that we wanted to use initially and designed our turbine around that. This is a multi-cat vessel which is available for around £4,000 a day compared to the £100,000 a day figures for the DP vessels for seabed structures. So we developed the turbine around the vessel, and the only way to make use of that vessel for installation is to have a floating self-buoyant structure, as you see there. And when you put the two together, you've got a very low cost installation and maintenance method. I think most of you have seen the video before, but just to take you through the installation procedure, we tow the device out to site with our small boat. Our rotor legs are retracted underneath the vessel, underneath the turbine initially to give us a low draft so we can get in and out of harbours very easily. When we come onto site, we lift up the mooring system into position with an onboard winch and make an electrical connection to the grid at that point. We then lower the rotor legs into position with a hydraulic system, and once they're in position, we release the brakes and the rotors, and off we go. This whole procedure is now taking us between 20 minutes and half an hour to complete on site, which is very important when you're working in high tidal flows and limited slack tides. In 2011, we completed the construction of our 250 kilowatt prototype. We built that over at Harland & Wolff in Belfast and launched the machine beginning of 2011 and carried out a 3-year test program at EMEC. This is just some video of the machine on site at EMEC at the end of last year. So you can see the very good stability the system has. This is connected to the mooring system, connected to the grid. We're putting power into the grid almost at full power in this video. We've been 3 years into the test program and have had very few, no major failures, no blade breakages, no structural issues. Mooring failures are electrical, which is reasonably unique in the industry, I think. This is some shots of the underwater shots of the rotors turning. 2 counter-rotating rotors give very good stability in tidal flows, and the system passively aligns itself to tide in any direction. This is the SCADA interface to the system, which we use to control the turbine, both manually and fully autonomously. All this was developed in-house, so we've got an awful lot of learning from the test program over the past 3 years. We're now winding down the test program of the 250 turbine and are moving on to bigger things, which I'll tell you a bit more about later. EMEC came in and did an independent performance assessment for us around this time last year. We were only the second wave our tidal turbine developer to go through that process. And EMEC did an extremely good job for us on that, assessing the performance of the device and verifying our power curve. Put plenty of power into the grid at this stage. This is over a 3-hour window of operation. So based on the success of the 250 test program, we're now moving on to a much bigger machine. We're going for a 2 megawatt machine, the SR2000, which we'll be installing early next year, again at EMEC. So we've started construction of that machine. We've taken delivery of our power takeoff equipment. We're assembling that up in Orkney, and I've just started placing orders for the construction of the superstructure. I'm not quite able to tell you where we're doing that just yet, but we'll be making an announcement in the next few weeks, but it will be within Scotland. So this machine, as Ray said earlier, comes with a price tag of £6 million. That's £3 million a megawatt, which is where we feel we need to be competitive with offshore wind. If anybody in the audience would like to buy one and has their checkbook with them, please come up and see me afterwards. I always make the point on the importance of using the learning from the wind sector in tidal. If there's a need to design bespoke, customized equipment for seabed turbines, the starting costs are going to be very high, and the learning rates to get the costs down in the equipment, I don't feel are going to be there. So what we've done is taken what learning has been gained from the wind sector. We use as much standard components as we can. ABB, who are an investor of ours since the start of last year, also supply a significant amount of technology to the turbine system. So our generators, low voltage power converters and transformers all are standard catalog equipment. So we've taken delivery, as I say, of our power takeoff equipment, and are assembling that equipment up in Orkney over the next few months. We assemble all the equipment onto equipment skids, which are then shipped down to the fabrication yard for final assembly into the turbine before launch. So as I said, we'll be launching the 2 megawatt machine early next year. We've got a 4-year test program planned at EMEC for that for the demonstrator. We intend, after a commissioning phase, we intend to get to the point where we're operating the project commercially. The machine has the potential to generate over £1 million a year in revenue with the 5 ROCs feed-in tariff. And we're also progressing our first commercial array sites. We don't have plans to become a project developer. We tend to have a more short-sighted view on things and feel that what we as technology developers need to do in the sector is reduce the technical risk to a level that is acceptable for project developers and utilities to come in and buy turbines and develop sites. We're doing some level of project development, but with the grid issues at the moment, it is inevitably slowing things down somewhat for us. We are progressing a 30 megawatt site in Orkney, Lashy Sound. The timescales for grid coming to Orkney keep getting pushed back, but so for now we're keeping the blinkers on and making sure we get through the technology development phase with the 2 megawatt machine and wait for the market to be ready, I guess. So this presentation was mainly about reducing cost and risk, and I think I've explained how we've reduced costs in our technology. Reducing risk. Risk is a mixture of both likelihood and severity, and the likelihood of things going wrong in this type of technology development is very high. We feel that it's very important to reduce as far as possible the severity of when things go wrong. The onshore and offshore wind sectors have shown that the majority of maintenance interventions are to deal with small failures of small components. So it's not necessarily the cost of the component that's the problem, it's the cost of getting to the component in the first place that's the issue. With anything on the seabed, subsea engineering approach, the cost to retrieve a turbine from the seabed are very high. With floating technology, which is surface piercing, we have 2 options. We can access the machine on site with a small REB. For bigger elements of maintenance work, we can disconnect the machine from its mooring system and tow it back to harbour for maintenance at harbour side. But both approaches are significantly lower cost than retrieving equipment from the seabed. So as I said, the importance of on-site maintenance and not putting things on the seabed is demonstrated here. Over the last 3 years, we've carried out over 100 access operations of the machine on site, and we have very tight health and safety procedures in place to control how that work happens, and that's all fully agreed with EMEC before we go and do any operations on site. So we've learned an awful lot from the test program of the 250. I'll start to finish up on costs. as I said, the importance of applying learning from the wind sector is very high. I mean, the starting costs for wind about 30 years ago had wind at around 200 euros a megawatt hour back in 1984. Learning rates of around 10 to 15% drove the costs down to where we are today, where wind is almost at grid parity with other forms of generation. Those cost reductions came over a period of 30 years and well over 100 gigawatts of installed capacity. Wind is now heading for around a terawatt of installed capacity by around 2020. So where is tidal going to be? This is where we feel the standard approach to tidal is going to be, starting off with high costs and eventually getting down to the kind of learning rates and costs that have applied in onshore wind. But we feel that it's going to take too long to get there. The big question is who is going to fund that early stage high risk period. Ray has talked before about the need to jump from one cost curve to another, and this is where we feel we come in. Applying a floating technology really means that we're on a different cost curve to the seabed technologies. So we expect to be able to hit the kind of £100 a megawatt hour target figure well in advance of the kind of gigawatts of installed capacity. We expect to be there within hundreds of megawatts. I think that's probably it, John, so thanks for the prompt. But yeah, just to finish off, sorry, I do feel the need to remind people of the size of the tidal market. Many people in the industry still, I think, feel it's the next wind. It's not quite the next wind. 50 gigawatts of installed capacity worldwide, we think, is about the maximum potential, which again demonstrates the importance of bringing in cost savings and reductions as soon as possible in order to be able to cut it against the other generation technologies as soon as possible. So I think that's it from me, and as usual, the closing message is the future is bright and the future is floating. Thank you.